Well, hello there. Hope you're doing well today. We're kind of in an awkward spot because you guys just finished the chapter on motion, and we're actually going to start dipping our toes into the next unit before we've actually taken the test on motion. That's just kind of a byproduct of this kind of crazy school year. So just kind of don't forget the old stuff. You got a test preview yesterday, and hopefully I've been able to answer some of the questions you might have about that. That test is on Thursday. Just make sure you're ready for it. Don't forget about it. That's coming down the pipeline. But today's topic, thank heavens, is actually very closely linked with our last topic, okay? Because motion involves the velocity of an object. And we're going to use that as our starting point for today. So make sure that you have your pencil sharp and ready to go here. And we'll learn a few things, so pause your tape if you aren't ready, but then get up and ready to go. We're going to learn today about a topic called momentum. Okay, so write that on the headline of today's notes, momentum. And the question you got to ask yourself is, what do you think the momentum of an object depends upon? A lot of times we'll say, hey, a sports team has momentum, or a political candidate has momentum. What does momentum mean in a physics sense? Okay, that's going to be what we are looking at today. If we say an object has a lot of momentum, what does that really imply? What does that mean? How do you know something has more momentum than something else? So let's take a look at this idea. Okay, and I've got a rather large truck and a rather small car there. If these two objects were traveling at the same velocity, would they have the same amount of momentum, or would they have different amounts of momentum? And if so, which object would have more? Another way to think about it would be, let's say we've got a rabbit and a tortoise who are racing. Let's say they both have the same mass. They both have a mass of 2 kilograms. Which of these is going to reach a greater momentum? So you see that these are actually kind of flip sides of a coin here. Here we've got a truck that has a lot more mass than this car, and they're traveling at the same velocity. Here we have a tortoise and a hare that are the same mass, but might travel at different velocities. But I think in each case, all of you out there in TV land can probably recognize that one is going to have more momentum than the other. That's because intuitively you know that this is our equation for momentum. And so I would ask that you write this for sure in your notes, that momentum equals mass times velocity. And since we measure velocity in meters per second, and we measure mass in kilograms, we're going to kind of use the mouthful of kilogram meters per second to describe what momentum is. But momentum isn't just this kind of abstract concept. We can actually calculate it. If you give me the mass of an object, tell me the velocity of it, I will be able to tell you its momentum. If I have a 1 kilogram object moving at 1 meter per second, that object will have 1 kilogram meter per second of momentum. It's measurable, okay? So the way that we write this equation in shorthand is P equals mv. So here's your m, that's mass, velocity is v, that makes sense. Where the heck does this P come from? Well, m was already used up. So the guy who came up with this was Sir Isaac Newton, and he just labeled it P, and it meant something to him. It basically meant the progress of an object. So P equals mv, that's going to be the equation that you're going to go with. So again, as before, if you set up a little triangle here, those can be helpful. A lot of you would help yourselves out a lot more if you would try using some of these little skills to help you out. So if I want my momentum, I just cover this up, mass times velocity. But also, I get 3 equations for the price of 1 here. If I want my mass, it's momentum divided by my velocity, that little fraction there. If I want my velocity, it's momentum divided by mass. It's pretty easy. So, let's look at how you'd solve a problem with this. And every time we have a word problem, guys, you got to imagine life is a word problem. Life is just taking situations and figuring things out. So we've got an 85 kilogram runner moving at 2.5 meters per second. So I've got my P, I've got my M, I've got my V. That's going to be my little equation triangle to help me out. So what is the problem giving us? Well, they're giving us the velocity. The velocity is 2.5 meters per second. I can recognize that right here. moving at 2.5 meters per second. And they're also giving us the mass. The mass equals 85 kilograms. So again, if you use this guess method, guys, you literally cannot go wrong. You identify what you know. What is the unknown? What is momentum? They don't know it. That's why they're asking you. It's the unknown, and I'm going to sneak in this variable P, which doesn't make a lot of sense, but you'll get used to it. P stands for momentum. Okay, so the equation I'm going to use is the equation we first came up with. P equals mass times velocity. So you can see in our first examples, the reason why the truck had more momentum than the car, even though it traveled at the same velocity, is because it had more mass. So this momentum is going to be a bigger number. You can see in the situation with the tortoise and the hare that even though they had the same mass, that if the hare has a greater velocity, that it's going to have a greater momentum. So both factors play a role. So I'm going to substitute in my momentum equals my mass of 85 kilograms times a speed of 2.5 meters per second. And when I solve that, I'm going to get the fact that this says that momentum equals, and I'm going to round this to the right number of sig figs here, 210 kilogram meters per second. There's my answer. Box it up, ship it out. I just solved this problem. That is the momentum of the runner. If I had a runner that had twice as much mass, it could run at half the speed and still have the same amount of momentum. That's the way this works. So a parked car's brakes give out, and it moves at 4 meters per second down a hill. Its momentum is 3,200 kilogram meters per second. So what is its mass? Well, that actually happened in this situation right here, and it ran over this picnicker right there. Bad day for a picnic. So here, look at what they're giving us. Moves at 4 meters per second. You've got to ask yourself, is that a momentum? Is that a mass? No, it's a velocity. So I'm going to write down V equals 4 meters per second. Its momentum is 3,200 kilogram meters per second. So I'm going to, again, use this kind of crazy letter P, 3,200 kilogram meters per second. That's my momentum. My unknown is the whole reason we have this problem to begin with. What is the mass? So the equation I'm going to use, remember I had P equals mv before, but here if I want my mass is going to be P over V, P divided by V. I just have to put a little twist on it, but if I ever was confused, I could just go back to this triangle here. That will help clear up any confusion I might have. So I substitute in mass equals a momentum of 3,200 kilograms meters per second divided by my velocity of 4 meters per second. And looky here, the mass of that car, 3,200 divided by 4, that car has a mass of 800 kilograms. Lickety split. All good. So that was a brief intro into momentum. There's a secondary video that is attached. I'd ask that you watch that. It might help clear up some things. And there's an assignment for tomorrow. It's relatively short, but I want you to submit that to me by Google Classroom. And do not forget that you have a test Thursday. You guys and the other cohort are all going to be working together on some online simulations dealing with momentum tomorrow, but this should be your main primary concern. Hope you guys have a good day today. Please send me a chat or an email if you've got questions. Have a great day.